Good morning, everybody. We are the group from Tri-Tek Engineering, and we designed the Tall Oaks Commercial Flex Industrial Development. My name is Bo Mackey.
I'm Aaron Bartley.
I'm Pat Smith.
All right, and just a quick overview of our presentation real quick. I'm just going to be going over the initial client goals and introduction, as well as the grading and erosion sediment control, while Aaron will be going over storm network and Pat will be going over the water and sanitary, as well as the conclusion. So our site location, just relevant from here, it is in Northern Virginia. It's located in Loudoun County, so if everybody knows where they are here, it's about 4.5 hours northeast of here, so I'm sure a lot of you guys are from Northern Virginia. And it's located just outside of Washington, D.C. to the west, between Reston and Leesburg right there, and it's just outside the 495 Beltway. So here's our existing conditions site. It's about 10 acres, and it's completely wooded, and it's undeveloped currently. It is in a pretty commercial district, as you can see by the two parking lots and large buildings. And it's zoned for a planned development industrial park. So as we're going to be developing an industrial facility, we didn't need to change the zoning at all. There's no existing utilities on site, and it's actually currently a gravel road that's the only access to the site that runs along the north right there. And it's an extension of Marie's Road, which is paved. And the site is very flat, actually, with 0 to 5% slopes. And there's wetlands at the north of the site right there. It's about 1/3 of an acre, and we're actually going to remove those wetlands. So client goals, the improvement of Marie's Road was a big thing. The end of the paved road is significantly north of the site, about 500 feet, and we have to actually pave the road all the way down to the bottom to the south of our site. And as well as design a flex industrial facility, which if you're not familiar with what that is, it's basically a large 50 to 75,000 square foot building. And it's mostly a large warehouse, and it has 25 to 35% office space with parking, and it has loading bays located along the back. This building is roughly 100 by 500 feet, so it's very long and rectangular to allow extra loading areas, and the pavement elevation is actually 4 feet below the finished floor elevation, which was significant in our grading. So here's our site plan overview. This is actually our conceptual layout. From the beginning, as we had to design for two buildings, the building to the east is the building that is proposed and that actually will be constructed, while the building to the west is just a future development, which we only designed for in our conceptual plan. This is our actual site. This entire area is just going to be grass area for the future building, while this will be our proposed building that will be constructed. It's about 52,000 square feet. You can see here traffic will be coming from the north and car traffic will just be coming into the parking area where the front of the building will be located, while truck traffic will be able to come into our site access, our access road into the loading bays. And you can see the water and sanitary lines which run through the site, and then the stormwater management pond down at the bottom. We have about 169 spaces shown on our concept or our layout right now, and there's only 131 required parking spaces. So our grading was relatively easy with just maximum 5% slopes, but we actually had 8,000 cubic yards difference in fill, which is rather significant, and we understood that if we just lowered the building pad by about 1 foot, then everything would be balanced out from that. And just from the roads, as you can see, it's just 1% longitudinal slopes with typical cross sections, so the roads were relatively easy to develop. Erosion and sediment control. We have 2 sediment basins on site, one at the top and one at the bottom, and these are separated into 2 drainage areas located just as you can see from this large drainage divide across the middle. We have diversion dikes to assist in those and draining into the sediment basin, as you can see, and then silt fence along the outside to keep all sediment onto the site, as well as a construction entrance. Temporary seating, as you can see, is only placed right here, as that will be where the future building is going to be, as well as a stockpile area with a silt fence surrounding it. Our phase 2 measures include dominantly inlet protection, as we have a rather large amount of inlets along Marie's Road, as well as around the parking areas. So those will need to be protected to protect the stormwater system. And then permanent seating, as you can see, will be placed in the large grass area where the future building will be placed, as there won't be any construction there after the initial grading of the site. And also the phase 1 Erosion sediment control, sediment basin is the same as our stormwater management pond, which we will just dredge out and convert into a permanent stormwater management facility. I'll let Aaron take it over next with storm.
Thanks, Bo. All right, I'm going to cover the storm network and detention pond. Start with the pre and post development delineations. The pre-development delineations contain 3 watersheds. The watersheds roughly divide the site from north and south. So we tried to follow that with our grading. As you can see here in the left picture, those delineations are our post-development delineations, and we tried to get those to flow down to our new detention pond at the bottom there. And then on the bottom right here is our Maurice Road delineations. They will flow into the Maurice Road network. And we produced over a 500% difference in runoff between our post and pre-development. So I'll talk about the storm network. Start with the inlets. We have 4 main systems. Start with Maurice Road. The top right, we have grade inlets that will collect all the water from the north of that. And then down here in the bottom left, we have 2 sag curve inlets that will collect all the water at that low point there, as you can see right here. And that's the plan view of Maurice Road there. Next system is the access road, which we have split into 2 separate sides with a high point in the middle of the road. The top of the road will flow into the Maurice Road network up here into this inlet and flow into the Maurice Road, and then the bottom will flow down into our southern parking lot and meet into these 2 inlets and flow into our detention pond. Next is our loading bay area. We have 2 grate inlets that are placed within the loading bay. This will take about half the runoff from the building, the loading bay, and the grass area to the left of there. And then we also have the eastern parking area, which will we have 2 inlets located there at 2 low points. They will flow to these 2 down here that are the southern parking lot again, and they will collect at the detention pond. And this is the 9 and 10 inlets again on the left side of the southern parking lot. The horizontal pipe layouts, we got the detention pond pipe layouts right here. You got the 9 and 10 down here again, the loading bay in the middle, and then the parking area there on the right. And then the Maurice Road again, showing the sag curve and then the grade inlets up top. And for pipe sizing, we went with 15-inch pipes for all our pipes. We used the rational method to determine this. The only exception was the 12-inch pipe here between 9 and 10. We had to do that. We had to have that inlet there to prevent ponding at that island. So the next thing I'll talk about the vertical alignments. Pretty much everything was normal except one constraint with our loading bays. Because they were so low compared to the parking area to the right, the loading, we had to drop the pipe network down to the detention pond, causing the bottom of the pond to be at an elevation of 298 feet compared to the starting point at 306 in the detention pond. You can see in the profile where it jumps up and it goes back down. So our detention pond, it was determined to be 18,000 cubic feet. You can see the plan view here. We got the 3 inlets coming in, and then that's going to be our outlet coming out. You can see this outlet flowing out here. We decided to go with a dry pond, and we were able to meet the post-development flows to meet pre-development flow. We're only constrained by the easement. It was only a 10-foot easement, so the maximum pipe diameter that we could use was 18 inches. So, but we were still able to meet that using the 18-inch outlet pipe. So, next, I'll move on to Pat with wet utilities.
Thanks a lot, Aaron. Like Bo said before, I'm going to cover wet utilities very briefly and the cost estimate and try to wrap everything up as fast as I can. To start off, to review the client goals, they need the water line to loop from the northeast right-of-way of Mary's Road all the way down to the southwest of the lot west of ours. Sanitary line needs to connect from the building down to the same area in the southwest. The owner of the adjacent properties allowed us to throw an easement in there. Our design approach pretty much followed the procedure of the Loudoun Water Engineering Design Manual and all the other Loudoun County zoning requirements, facility standards manual. Our plan view, basically, we started off at the top, building connection at the northern face of the building. We ran down the center of the loading dock so we didn't interfere with the future building. It's going to be on the west side of the loading dock. We hugged the southern border so we didn't interfere with any future development in Lot 6. Fire hydrant flow, we were able to fulfill Loudoun County's requirements for that, which is 2 hydrants. Profile view, we kept between 3 and 6 feet of cover. Pipe sizing, we followed the same procedure that was in the engineering design manual. Sized our pipes using Bernoulli's equation, realized that 8-inch ductile iron pipe was best for the water. Sanitary sewer pretty much ran parallel to the water line. 12-foot separation, kept over 6 feet of cover, and minimized our pipe slopes. Pipe sizing was done using the engineering design manual as stated before. 8-inch PVC pipe was selected using Manning's equation. Cost analysis, total cost was just over $2 million. And just to recap, we followed all the client's procedures. We not only did that, we did so with the county requirements, and we think that we did an efficient and economically feasible design. We'd like to thank you all for your time, and mentors Kevin, John, and Brian for all their help. Does anyone have any questions?
Why did you guys have to remove the wetlands?
Well, we actually, in our value engineering, when we designed for the second building, we removed them because if they were to develop the second building, then they would have to, because the buildings themselves take about like 25% of the site. But in our value engineering, we said if you were to, if the client were to decide not to build the second building, then it would actually save like roughly 70% of the wetlands, which saves cost of about $30,000. So we put that in the value engineering, and in the end, to save some money if they wanted to have that option.
Other questions? Kevin, you want to get off?
Everybody else pick at it. I picked at them all semester. You did.
Okay. Very good. Thank you, guys. All right, that concludes our final presentations, and I'd like to just offer a couple of comments from my perspective. I'm extremely proud of the students in my class. The presentations this morning were very professional, very well done, very practiced, and the quality of engineering shown throughout the last 4 months is very good. You guys, we can tell you put a lot of hours in. Am I right? Is that an understatement? I think the mentors know as well. But what I'd like to have you guys do is thank the mentors for all of their help. Would you help me do that? They volunteer their time and their expertise, and probably put up with some exasperation on your part during the semester at certain times, and handle it quite well, I'm sure. It's tough. It's a learning process that some of them have gone through in this class, and they know what it's like. So those folks that didn't go through the class learned it somewhere else, and I'm sure found it just as frustrating. And it's not easy what you've just gone through, but it certainly will help you in your future career.